Hello 8th graders and welcome to Math Weekly number 2. Our focus skill for today will be proportional relationships. The definition of a proportional relationship is two or more ratios that are equal in value. In other words, they show the same relationship in a different way. In your own words, you may describe it as more as repetitively adding the same amount and less as repetitively taking away the same amount. So if we go back to our first screen here, we can see that this chart constantly increases by 3 pencils with every one student. So every student that we add, we would add 3 pencils. Every student that we take away, we would take away 3 pencils. So it's proportional because it shows the same amount, 3 pencils for every student. And we can also add more or less by repetitively adding the same amount. You have experience with proportional relationships. If you've been to a music store and you've seen each CD in the sale bin is $5, you can start to make proportional relationship ideas in your mind. If I buy 0 CDs, my bill is $0. If I buy 1 CD, my bill is $5, and keep repetitively adding $5. If I buy 2, it'll be 10, 3 will be 15, if I buy, and so on, creating that proportional relationship of adding $5 to the bill with every CD that I own. Maybe you worked for your farm on your pap's farm this summer, and maybe he paid you $7 an hour. You can start to make proportional ideas from this situation. When you work 0 hours, you get paid $0. If you work 1 hour, you get paid $7. 2 hours, 14. 3 hours, 21. And when you work, and so on, and repetitively adding $7 each time. Even when you go to the bathroom and you look at the toilet, you can see there is a proportional relationship there between the amount of gallons you use in each flush. If you flush 0 times, you'll use 0 gallons. 1 flush results in 1.5 gallons used. 2 is 3, 3 is 4.5, and if you flush whatever, you can multiply that by 1.5 and figure out how many gallons are used. These are proportional relationships. Now I want you to hone in on a few things that you may or may not have noticed. All the proportional relationships we just described started with 0, 0. If you work 0, you get 0. If you buy none, you get none. Or you pay none. If you flush the toilet 0 times, you use 0 gallons. Every proportional relationship starts with 0, 0. If we are looking at a graph, that means that the line will pass through the order pair 0, 0, which is the origin. This is a quick indicator of a proportional relationship or not a proportional relationship. Also, notice all the proportional relationships we described had a constant rate of change. That means that they will look like a straight line on a graph. Both of these must be true in order to be a proportional relationship, so you need to check. Is 0, 0 part of the relationship? And does it have a constant rate of change? So let's look at these 4 graphs. Does each graph to the right represent a proportional relationship? Why or why not? So let's begin by looking at graph A. We see that it's a straight line. That means that it has a constant rate of change. It's constantly going down 3 each time it goes over 1. Down 3 and over 1. Down 3 and over 1. So yes, this has a constant rate of change. However, it does not pass through 0, 0, the origin. So this is not a proportional relationship. It does not go through 0, 0. Let's look at graph B. Graph B is also a straight line, which means it has a constant rate of change. It goes up 1 every time it goes over 3. Up 1, over 3. So this is a unit rate situation. It has a rate of change. It also passes through 0, 0. So it has fulfilled both qualities. Constant rate of change, 0, 0 is part of the relationship? Yes, this is a proportional relationship. Look at C. C does have a constant rate of change, but it does not pass through the origin, so this is not a proportional relationship. D has a constant rate of change and passes through the origin, so yes, it is a proportional relationship. Let's look at another example where we are given order pairs and a chart. The order pairs and chart below show the cost of an electrician driving to a site and working for a certain number of hours. And we can see the hours that they worked and the resulting amount of money. We want to know, does this represent a proportional relationship? Is it increasing by the same amount every time? Well, we can see it's going up $10 in 1 hour. It again went up $10 in 1 hour. Here it went up $20 in 2 hours, which is the same as $10 each hour. And here it went up $20 in 2 hours, which is the same as $10 an hour. So we just showed that it has a constant rate of change, which is $10 per hour. Now remember, that's only half of what we have to check for a proportional relationship. We also have to make sure 0, 0 is part of the relationship. So let's back it down. If we work 1 less hour, we'll get $10 less, which would make it $35. If I work 1 less hour, so 0 hours, and I take away $10, that's $25. So is this relationship 0, 0? Work no hours, get no money? No, because there is a cost for driving to the site. So this does not represent a proportional relationship because 0, 0 is not part of the relationship. So let's summarize. A proportional relationship is 2 or more ratios that make the same comparison. They always start with 0 equals 0. And we can see in the example here, 0 students need 0 pencils. On a graph, that means that it's going through the origin. And it has to have a constant rate of change. There are 3 pencils for every student. Get another student, need 3 more pencils.